In this tutorial, we're going to learn how to estimate internal consistency reliability using Cronbach alpha in R. So to get started, we need a data file that we can work with, and this is a comma-separated values or .csv data file, and it's called survey, all lowercase here. And so this is the data file that we will read in and that we will work with today to actually practice estimating internal consistency reliability using Cronbach alpha. So to orient ourselves to this data file here, you can see that the first column here, this variable is our unique respondent identifier or survey ID here. And so these just are just numbers that are unique in nature that represent each survey. And so each row here then is the survey data for a single respondent or person in this case. So then you'll see the variables that come to the right, or the columns that come to the right, are our variable names here. And you'll see JobSat1, JobSat2, JobSat3. These three variables represent three different job satisfaction items or questions that are meant to make up an entire measure or scale. So this would be a 3-item job satisfaction scale or measure. Then we have turnover intentions or turn-int 1, 2, and 3. This means that we have a 3-item turnover intentions measure or scale, and then we have a 4-item engagement scale here. And so we're going to be practicing here today running Cronbach alpha, which is an indicator of internal consistency reliability, and we're going to be doing so using the alpha function from the psych package. But before doing that, we need to get into RStudio and we need to set our working directory and read in our data. So next thing that we're going to do is go to RStudio here, and you can see when we open up a new session, you'll likely see the version history and so forth here in our console. We can go ahead and go to Edit and Clear Console. Again, that's Edit, Clear Console in the drop-down menus to clear that out so we can start with a blank slate. You don't need to do that, but I like to do that at the start of every session. It's good to work with an R script editor, and this will allow us to create an R script file where we can track our work, create annotations and so forth. It makes it easier to share code, work collaboratively with code, and to make more reproducible code. So to open up the R script editor window, you go to File, New File, R script. Again, that's File, New File, and R script from the drop-down. Now we have our R script editor open. And so the first thing that I'm going to do is to start off with an annotation, and I'm using the hashtag symbol here. So anything that goes to the right on that line becomes a note or an annotation that won't be treated like a command in R. And I'm just going to remind ourselves what is the purpose of today's tutorial, which is to estimate internal consistency reliability using Cronbach alpha. So that's going to be our focus here for today. And so what is internal consistency reliability? Well, when you're working with multi-item measures or scales, estimating the internal consistency reliability of those scales or measures is a common step in building a case that the items within that scale are homogeneous. Now, homogeneity among items provides some evidence that the items are reliably measuring the same construct or concept. So for example, if we'd like to measure job satisfaction, it's typically the case that one item or one question from a survey probably won't gather the whole or capture the whole concept or construct domain that represents job satisfaction. And that's why we typically have multiple items to get at different aspects of that domain or that concept. And so in this case, in the sample data we were going to be working with today, we have 3 different items that are meant to tap into, so to speak, job satisfaction, and we want to understand their internal consistency. In other words, how homogeneous are these items? And this is often a first step in determining whether or not it's appropriate to create what's called a composite variable or overall scale score variable based on the average or the sum of a person's scores on the different items from a particular measure. Okay, so again, internal consistency reliability is often a first step or one of the steps that we might use when trying to justify whether it's appropriate to create a composite variable when we assume that, or we would like to assume that all the items are measuring the same thing. Now, of course, just because we are consistently measuring the same thing doesn't always mean or necessarily mean that we are measuring the right thing or what we intended to measure in the first place. And so this echoes the notion that high reliability is a necessary but not sufficient condition for high validity. But nevertheless, internal consistency reliability is a useful form of reliability when it comes to evaluating multi-item scales or measures and determining whether it is appropriate to create a composite variable, which is sometimes called an overall scale score variable. All right, so As I mentioned before, one of our first steps before we get into actually using Cronbach alpha or estimating Cronbach alpha and internal consistency reliability, we are going to need to set our working directory. We'll use the setWD function, or at least that's what I'm going to use here. It's setWD all lowercase, and within the parentheses as a sole parenthetical argument, I type in quotation marks, and I'm going to type in the exact name of the path that leads to the folder where the data file, which is called survey, which is a comma separated values or .csv file, is saved. And it's my H drive, R workshop folder is the exact name and path here. I happen to know that off the top of my head. It's a pretty short one for me. And I can click run there to set that as my working directory. And so how do I know what to set my working directory as? Well, if I come to my H drive or workshop folder, I'll see that that data file that's called survey all lowercase is saved there. So this is the file I want to read in. It is a comma separated values file. So I need to put in the name of that working directory or that path that I'd like to set as my working directory. Now, alternatively, you could go to session, set working directory, and choose directory from the dropdowns. Again, that is session, set working directory, choose directory from the dropdowns. And you, by default, if you already set your working directory, it'll take you directly to where that folder is. Alternatively, you could search around, find the folder, and then when you find the folder that you'd like to set as your working directory, click open. You'll see down here in your console, you get the output there that confirms that this is the function that you're actually running behind the scenes with those dropdowns. You could copy this. We could pretend like I never typed anything in here like this, paste it in, and that's the alternative way to set your working directory. I do recommend pasting your working directory or your setWD function and your path into your R script, and that way it just makes it faster and easier the next time you open up an RStudio session, you want to access that same working directory. It's already there for you, and you can just click run like I just did there. Okay, so we have set our working directory. Now we are going to read in the data. And so our data file, if you recall, is called survey all lowercase, and it's a .csv or comma separated values file. So the first thing that I'd like to do here is read in the data and read in those data as a data frame, and then assign that data frame to an object that we can subsequently reference in our alpha function that we're going to read that comes from the psych package. So first, I'm going to come up with a unique name for the object that I'd like to assign the data frame to when I read it in, and I'll just call it df. And just df, let's say it stands for data frame, and it's all lowercase there, easy to remember, somewhat generic there. And I'm going to use the left-handed arrow operator. Again, that's a left-handed arrow operator, so it's a less than symbol followed by the minus symbol there to create a left arrow there. And then to the right of that left-handed arrow, I'm going to type in the name of the read.csv function. That's read.csv, all lowercase. Type in the parentheses, and as a sole parenthetical argument, assuming we have set our working directory above and the file exists in that working directory, type in quotation marks, and then the exact name of that file followed by .csv. So remember, the exact name of the file was survey, all lowercase. And then make sure that you add in the .csv file extension there because this is a .csv file, and you need to do so in order to use the read.csv function. Okay, now that we have that all there, you can highlight the whole line or put your cursor somewhere on the line and click run. All right, the next thing that you'll see here is that we have a new object in our global environment here, and that is our df object we just created. It has 156 observations, which in this case is unique survey respondents here, and 11 variables, which we previewed at the beginning of this tutorial. So let's take a peek at the data here. We could click there to view it in a tab here, but let's practice using the head function, and that's just HEAD all lowercase to look at the first 6 rows by default of that data frame. And so just copy, and paste into the parentheses there as the sole parenthetical argument in the head function, the name of our data frame object. Click run. And so now you see just the first 6 rows of data and all the variables there. It looks like it read in just fine. So I think we're ready to practice using the alpha function from the psych package. So the first thing that we're going to need to do is to install and access the psych package. Now, the psych package is a great package if you're looking for psychometric functions, such as to estimate Cronbach alpha, which again is an indicator of internal consistency reliability. So the first thing that we want to do, if we've not installed the psych package yet, or we haven't done so recently, or would like to update it, we type in the exact name of the install.packages function from base R. Because it's from base R, it comes with the standard installation of R, which means you don't need an outside package to use the install.packages function. Again, it's just install.packages, all lowercase. As the sole parenthetical argument, and within quotation marks within the parentheses, type in the exact name of the package. In this case, the package is all lowercase, and it's psych, P-S-Y-C-H, psych. Now, I have very recently installed this package and used it, so to save time, I'm not going to click run because that can sometimes take a little bit of time as it's installing. But if you've never used this package before, definitely run this line of code. Otherwise, you can skip down here, and if you've recently installed this package and have access to it, the next thing we need to do is to actually pull up the package so we can use its functions. And so we'll use the library function from base R, which is library, all lowercase, and as a sole parenthetical argument, I'll just copy in the exact name of the package, and you don't need to put it in quotation marks here. So type in the exact name of the package and click run. Now, if all goes well, you'll probably see blue font down here. And in this case, it means that we should be able to access the functions from that package now. Okay, so the next thing, we're going to use the alpha function. So we're going to estimate Cronbach's alpha, which again is an indicator of internal consistency reliability. Fortunately, the name of that function from the psych package is just alpha, all lowercase. We add our parentheses. Now this will get a little bit maybe challenging in terms of trying to understand what we're doing with the arguments here in this function, or specifically the sole argument we're going to use for this function, because we're going to use what's called bracket or matrix notation here. So this is what this function requires. So the first thing that you'll type in is the exact name of your data frame object, which for us is just df, all lowercase. So df, and then we enter brackets. Okay, so brackets here. Now within the brackets, the first thing that we're going to type in is a comma. Okay, so why are we typing in a comma? Well, we're using bracket or matrix notation here. And what that means is that anything we put before a comma is going to reference rows. Anything after the comma references columns. In this case, our variables are the columns. And so we're going to put what we're about to type to the right of the comma. Okay? So first thing we're going to enter is the C function from base R, which stands for, you can think of it standing for combine. And this is how we create a vector. And we're going to create a vector of the exact variable names. And so to start off here, the first thing that I'd like to do is I would like to run internal consistency reliability for the turnover intentions items. Okay, so let's start with the turnover intentions items, which are turn int 1, 2, and 3 here. So as the first argument, type in quotation marks, and I'm just going to copy, to make sure I get it correctly, the exact name of the variable. And remember, R is case sensitive here, so it's capital T, capital I, and make sure you have the numeral 1 there as well. Okay, outside of the quotation marks, then type a comma to separate that first variable or argument from the next one. The next one is going to be turn int 2. I'll copy that, paste it within the quotation marks. Outside of the quotation marks, add another comma to separate that variable or argument from the last one, which is going to be within quotation marks, turn int 3. Copy that, paste it here. Okay, so now we have specified the function here. Again, we're using matrix or bracket notation within the alpha function here as the sole argument. Again, the name of the data frame, brackets, comma, and to the right of the comma, because we want to reference columns and not rows, the C function to name a vector or create a vector, and then we list our variables here. If you had more than 3 variables, then you would add in comma and so forth and the other variable names. If you had 2 variables, you would just do one. You wouldn't do this Cronbach's alpha with a single variable because, well, you need at least 2 variables to estimate the homogeneity of the variables or the consistency between them. Now remember, these variables here represent items from the turnover intentions measure or scale. So I think we're ready to run it now. So put your cursor somewhere on the line or highlight this whole line and click run. You're going to get a lot of output, and this can be kind of overwhelming the first time you see the output for this function. But never fear. And so here we get confirmation that we did. This is the code that we wrote for the alpha function. And in terms of the actual output, you'll see it here. And we see the reliability analysis here. And because this is what it is, it's an internal consistency reliability analysis. And remember, Cronbach's alpha is one way that we can estimate internal consistency reliability. All right, so the first thing, and there's really just a couple areas we want to look at in this output. The first is the raw alpha. And so below the raw alpha title here, it's raw underscore alpha, you'll see a value of 0.83. Well, what does that value mean? Well, in general, and I'll make a note here, adequate internal consistency reliability, or specifically Cronbach's alpha, is going to be we need greater than or equal to 0.70. Okay, so and that's a pretty conventional cutoff for most reliability estimates. If you're 0.70 or above in terms of the alpha, which again is an indicator of internal consistency reliability, that means we can say we have adequate consistency among the items within our scalar measure in this context. Okay, and so here you can see right off the bat, we see that the raw alpha is 0.83, that is above 0.7, and so we'd say, okay, this is adequate. So this actually has decent internal consistency reliability. Remember, we're referencing, in this case, the internal consistency reliability of this 3-item turnover intentions measure here, which is turn int 1, turn int 2, and turn int 3. Okay, so, but what are some other qualitative descriptors that we could use to describe if we're above or even below 0.70, kind of the level of internal consistency reliability? So here are some additional qualitative descriptors that we can use. And to save space, I'm just going to paste these directly in here instead of typing them all out in real time here. And so again, these are qualitative descriptors of Cronbach's alpha. As we've already learned, if it's a 0.70 or above, it's acceptable. And so really, if it's 0.70 to 0.79, that would be acceptable. But really anything above that would then roll up and be acceptable as well. But you can add some more additional niceties or descriptors in terms of indicating, well, if it's acceptable, is it above acceptable in the sense, do we have a more favorable reaction to the level of internal consistency reliability? So if it's between 0.8 and 0.89, we'd say typically, oh, that's good. If it's 0.9 to 0.94, that's great. 0.95 to 1.0, where 1.0 would be the highest possible, that is excellent. These are somewhat arbitrary, and these are just conventions that I've noticed people using. And other people might have different thresholds, but generally speaking, 0.70 and higher being acceptable is fairly commonly used, at least when we're working with people data, such as in psychology or human resource management, for example. Now, below 0.70, that's where you get into the 0.6 to 0.69 range, where I would say that's the questionable range. And then anything from 0, which is the low end or the floor of Cronbach's alpha, to 0.59, that would be completely unacceptable. And so why do I put in this questionable range here? Well, this is a range where if you really do have a scale, maybe it's only like a 3-item scale, and you find that, well, it's like 0.68, 0.69, you might deem that acceptable, assuming the items are well written and you think that it is tapping into what you think it's tapping into, and perhaps whether it has decent criterion-related validity. But for our purposes, if it's below 0.70, we're going to say that's just not acceptable. Okay? All right, so if we look at our raw alpha of 0.83 here, that would fall into this good range. So not only is it acceptable, but we might even add on the flowery language that it is good. Okay, so what does this mean? Well, right off the bat, it means that this scale looks pretty good. The 3 items turnover intentions seem to be relatively homogeneous. But the next thing that we're going to do is come down to the reliability if an item is drop portion of our output, and this table has some interesting information. And so what you'll see here is that we have a table with multiple columns. We're just going to focus on the first meaningful column here. So you'll notice to the left we have the names of our variables. In this case, these are items. So our measures items, which are turnover intentions 1, 2, and 3. Now, the way to read this, and you'll see the column is raw_alpha, is that this is the reliability, this value here, if this item is dropped. So for a 3-item scale, this is saying if we were to drop turnover intentions 1, the reliability would actually go from 0.83, which was the Cronbach alpha for the entire 3-item scale, to 0.75 if we just kept turnover intentions 2 and 3. In other words, we dropped turnover intentions 1 and kept the other 2 items. Coming down to turnover intentions 2 item, the second item here, it would drop even further in terms of the alpha if we were to drop the second item, but then keep the first and third. And interestingly, if we were to drop the third item, it would actually stay exactly the same. Our raw alpha would stay at 0.83, as the first 2 items seem to be really homogeneous with one another, and the third one doesn't really necessarily, it's not going to affect anything if we add or drop, or rather if we dropped it. Now, I would go ahead and keep it in, unless you were to look at the actual item content and find that, well, this turnover intentions 3 item isn't that great of an item, or it doesn't seem to be tapping into turnover intentions when we look at it from a qualitative perspective. All right, so that gets me to the next step. So you want to first start, and you can do this actually in different orders, but I would recommend starting with looking at your Cronbach alpha information, so the quantitative information about internal consistency reliability, but never underestimate the value of actually reading the actual item content to make sure that whatever the items are for a particular measure, that they seem to be tapping into the operational definition for that concept that you're trying to measure. So here in this example, we're trying to measure turnover intentions. So I'm going to copy and paste in, and these are just example items that I've written to correspond to the 3 items. So let's imagine that the first item turn into 1, the actual item content, and let's assume these are each evaluated by the survey respondents using a strongly disagree to strongly agree response format, which is what I envisioned for the sample data that we have here. So if you look here, we have responses 1, 2, 3, and 4, and 5 available for each one of these items here, or variables from these measures. And let's say that 1 corresponds to strongly disagree and 5 corresponds to strongly agree. And we've just converted that Likert type scale into a number here, or in other words, into a numeric scale here, okay, for the purposes of analysis. And so, for example, if someone responded to this item, they read it as, I regularly think about leaving this organization. And so they might indicate that they strongly disagree with this or strongly agree with this, and that would be their response. And then also that would equate to a score on that 1 to 5 score from strongly disagree to strongly agree I just mentioned. Well, this first item looks pretty good here. I regularly think about leaving this organization. That sounds like turnover intentions to me. I plan on quitting this job within the next year. That sounds like turnover intentions to me. Someone's thinking about quitting their organization. And then finally, I regularly search for new jobs outside of this organization. This looks like turnover intentions too. If you're looking for jobs outside of your organization, you're probably thinking about voluntarily leaving the organization. So this last item seems to tap into turnover intentions. And so even though dropping it wouldn't affect our internal consistency reliability, to cover the construct domain and this idea that people regularly search out new jobs as being part of turnover intentions, which I would say is part of the definition or the concept space for turnover intentions, I think it's important to leave this item in. So given the fact that Cronbach alpha, and I'll type this out so that it's clear. So given that alpha is equal to 0.83, so acceptable or good, more specifically, and the item content indicates each item appears to tap into the concept of turnover intentions, which is what we're trying to measure here, we should keep all 3 items. Okay, so we're going to retain all 3 items with the idea that we're retaining them because this could affect we'll retain them if we choose to create a composite variable, which means we're creating an overall scale score variable here to represent turnover intentions by, let's say, taking each person, their average response to each of these 3 items, and then that average becomes their overall score for turnover intentions, their overall turnover intentions, if you will. Okay, let's do a little bit more practice here, and let's go ahead and estimate the internal consistency reliability using Cronbach's alpha for the 3-item job satisfaction scale. So here we can see those 3 items were, and to get this pop-up window here, I just clicked on the name of the data frame object in the global environment, and here you can see there the 3 job satisfaction items are job sat 1, 2, and 3, and it's capital J and capital S for each one of these. All right, so how do we do that? So I'm going to make a note here. This is going to be job satisfaction measure or scale. Okay, so we're shifting gears from the turnover intentions, and we're actually going to go ahead and copy that code that we wrote above here. I'm adding in the annotation as well for the 3 turnover intentions because we can just easily adapt that here below. Okay, so to estimate Cronbach's alpha here, we're just going to type in the exact name. In this case, it happens to also be a 3-item measure here. So we just need to type in jobsat 1, 2, and 3 and replace turnint 1, 2, and 3 here. So remember, it's jobsat 1 with a capital J and a capital S, jobsat 2, and jobsat 3. Okay, so it's as simple as that. They're from the same data frame object, so we don't need to change anything else. Let's go ahead and run that. All right, so let's work through that output with this job satisfaction 3-item measure. All right, so the first thing we look at is the raw alpha here in the left-hand corner, and we see that it's 0.78. If we go to our interpretation qualitative descriptors here, well, it is above 0.70, so right off the bat, the 3-item scale is acceptable. Okay, and so it is within that 0.7 to 0.79 classic acceptable range there. The next question we have is, well, let's go down to this reliability if the item is dropped table, which is our next step. Could we improve that internal consistency if we were to drop one of the items? Well, let's take a look at this table. So if we were to drop jobsat 1 and keep the remaining 2 items, our alpha would actually fall from 0.78 to 0.62. So that'd make it worse. We don't want that. Same thing would happen with if we drop jobsat 2 and kept the other 2 items. Alpha would fall, and that's not good either. But what if we look at jobsat 3? If we look at the 3rd job satisfaction item, if we were to drop that item and keep the other 2 items, so specifically jobsat 1 and jobsat 2 we would retain, our alpha would actually go from 0.78 to 0.82. Now that might not be qualitatively, or in terms of magnitude, that's not a super huge jump there. It's 0.04 increase, but it might signal that there's something wrong or there's something problematic with this job satisfaction item. Maybe it doesn't seem to be measuring job satisfaction, or perhaps the issue is that it's not a well-written item to begin with. So I've created some hypothetical item content here to bring this to life, and let's assume that these items were rated by the survey responses using that same strongly disagree to strongly agree response Likert type format, where strongly disagree equals 1 and strongly agree equals 5 in this case. Okay, so here we can see that jobsat 1, the content for the item is, I enjoy completing my daily work for my job. Well, that sounds like job satisfaction. That sounds like someone that's satisfied with their job or the work that they're doing. So that seems to meet the conceptual definition for job satisfaction. What about jobsat 2? I'm satisfied with my job. Well, that seems right on the nose. That's a job satisfaction item there. What about the 3rd item? I am satisfied with my work and with my direct supervisor. Well, this seems like this might be a problematic item, and this might explain why dropping the 3rd job satisfaction item would actually increase our internal consistency, because this is not a well-written item. This is double-barreled here. There's 2 reference points. I'm satisfied with my work, and I'm satisfied with my direct supervisor. What if someone is only satisfied with one of these but not the other? How are they going to respond using that strongly disagree to strongly agree Likert type response format? So this indicates here that jobsat 3, that 3rd job satisfaction item, and it corroborates what we found above, that, and I'm actually going to copy this to save time and space. I'll type out the conclusion here. So given that the alpha is 0.78, which is acceptable for all three items together, but will increase to 0.84, or is it 0.82 rather, if we were to drop job sat 3 and take away the comma there, add some space. And so given that alpha equals 0.78, which is acceptable for all three items together, but will increase to 0.82 if we were to drop job set 3, and the item content for job set 3 indicates that it is double-barreled, so badly written item, we should drop job set 3 when making a composite variable or overall scale score variable for the job satisfaction measure. Okay, so we have that all in writing there. So this, I just want to make sure the logic is really clear here. We're using two sources of information and then we're corroborating that information, or we're seeing if one bit of a source of information corroborates the other. And so again, based on the reliability of an item is dropped, we found it signaled that there's maybe something problematic with that job sat 3 or something that could be improved. And in this case, it's signaling to us, well, we can actually increase the internal consistency reliability if we drop that item, and the item's not well written, and it's going to lead to ambiguity. So if we get someone respond strongly to agree, does that mean that they're satisfied with both their work and their supervisor? We'll never really know. There's too much ambiguity there. So we should drop that one. And in a future survey administration, this might be an opportunity to separate this into two items. Or just to what's really seemed to be missing is if you're defining job satisfaction to include satisfaction with your supervisor, just make a separate item that is I'm satisfied with my supervisor. But for now, we should drop job set 3. All right, so that wraps up the first two scales there. I'll leave it to you to work on the third scale if you'd like, which is the engagement scale. And if you would like to follow along with the 4-item engagement scale, so again, that is engage 1 through engage 4 there, so it's 4 items there, so think about what that'll mean to adapt your alpha function script here by adding an additional argument to your C function there in terms of creating that vector of variable names, which are specifically item names here. And so if you'd like to, I'll go ahead and give you some sample or example item content here for the engagement items so that you can use that along with your estimate of Cronbach's alpha to determine whether or not it would be appropriate to use all 4 items, or you'd be better served dropping one of these items, for example. All right, so this wraps up the tutorial on how to estimate internal consistency reliability using Cronbach's alpha in R.